To start off, we have to talk about the unit circle. This is an incredibly important concept in trigonometry, and we use it to better learn and understand angles. Okay, and it's pretty key for both coterminal and reference angles. Now, the unit circle, it's kind of in the name. It has a radius of just 1 unit, of 1. Okay, and if you draw a circle like this, okay, with this radius of 1, that means that it'll hit a couple of points. It'll hit the 4 coordinates that I show here. Okay, so this is 1, 0. This here is 0, 1. This here is -1, 0. And lastly, this is 0, -1. Okay. But this isn't the only part of the unit circle. If you go around in this direction, and this is counterclockwise, okay, you'll find that, and I've already marked them here, if I start right here, this is where you always start, this is 0 degrees. If I go around this way, I've gone 90 degrees. Go this way, I've gone 180 degrees. Go this way, I keep adding 90 degrees. That's the pattern here. I'm at 270. And then when I go back here to the beginning, I'm at 0 degrees, but I'm also at 360 degrees. Those are one and the same because I've made a full pass around the whole circle. A circle's total degree measure is 360, so that checks out. Okay. Now, if I make a line going from the origin to any point on the circle, anywhere between the 0 and 360, I end up with an angle. Okay, and that angle will form from this place that I started up until where it is that I stop at the line. Okay, this here is an angle. And in this case, let's just say that this angle is equal to 45 degrees. So let's say I'm smack in the middle, right between 0 and 90. Okay, this is why it's important to have this unit circle. You can visualize angles. Now I'll more explain how this has a use case in trig. So coterminal angles, well, how do unit circles help us with this? Well, we have to know the definition. Coterminal angles are angles that are equal to one another. So they differ in degree measure, but somehow they're still equal to each other. How's that? Well, take a look at this diagram it is that we have from before on the unit circle, and we're going to use the same angle of 45 degrees. Again, we're going counterclockwise with our 360, okay? If we think about this, when we go fully around the circle, 360 degrees, okay? So we're just going to follow this arrow here. I'm just going to go around all the way. I've hit here, okay? This is my 360 degrees. If I add my original angle and 360 degrees, that means I've made a full pass around and I'm right back where I started at this orange, dark red line. So a coterminal angle, it's going to end up being exactly where it is that my original angle is. The difference is just that I'm going around the entire circle. So the number gets bigger in this case, but they're in the same place, if that makes any sense. Now, is it possible for me to have another coterminal angle? Well, think about it. There is only one way to go around the circle. We've talked about counterclockwise, but what about if we turn it around and let's say that we try a different way. Let's say that we try counterclockwise. Or sorry, we already did counterclockwise, just showing it again. If we go, and I apologize, this is actually the wrong way. This is actually supposed to be clockwise. It'll actually be this way. There we go. Clockwise. So the way it is that we read clocks, right? That's actually going to be determined as being 360. So if we start again at our starting point at 0 degrees, we start from here, we go all the way around, look at where that arrow ends. If I do that and I end right back where my 45 is, okay, the way it is that you represent that is by subtracting. So going counterclockwise, you're positive, clockwise, you're negative. Okay, that's just the way it is that the unit circle works. One way is the positive, one way is the negative way. So not only can I add to get a coterminal, I can also subtract. So the two ways it is that you can get coterminal angles are just as described. You add 360 and you subtract 360 from the angle it is that you've been given. Okay. Now, you can do the same thing not only with degrees, but also with radians. With radians as well. So we have 0 pi, pi over 2, pi, and 3 pi over 2. So just remember how it is that you can convert between radians and degrees. Radians is the same thing as 180. It's pi. Okay, so 360 is 2 pi. All right. So if we added and subtracted 360 degrees, we can add and subtract 2 pi to get our coterminal angles. Okay, so let's try it. Let's say we have 2 pi over 3. Okay, and I want to figure out what my coterminal angles are. I'm going to add 2 pi. And here's the work it is that I show here. So I'm just going to go through each part. So take a quick look. We're going to go through each one by one. So see here, I start off with 2 pi over 3 plus 2 pi. What I did is I put 2 pi over 1 because when we're adding fractions, we want to make sure that, well, we have two fractions. 2 pi isn't a fraction on its own. I have to put it over 1. And then when I add fractions, I also want to make sure that my denominators match. So I multiply by 3 to the top and bottom of the 2 pi over 1. So my next line here will end up being, let's take a look here, it'll end up being 3 times 3, right? Multiply top and bottom by 3. When I combine, I should get 6 pi over 3. When I add up 2 pi and 6 pi, I should get 8 pi, and I still have the 3 on the bottom. I don't add the denominators of fractions. I only add the numerators. That's the rule of adding fractions. And then same for subtracting, similar rules. I take my 2 pi and I subtract. I had to put over 1 to subtract. Okay. I make sure that my denominators are the same. We already found out before when I multiply by 3 on the top and bottom, I get 6 pi over 3. When I subtract, I'm going to get something negative. It'll be negative 4 pi over 3. Here are my two coterminal angles for this problem. Okay, now moving forward to reference angles. Reference angles are, well, it's kind of in the name. They're a reference. It'll be some angle that'll be between 0 and 90 degrees. Okay, anything bigger than that is not technically considered a reference angle. You can just kind of consider it as the smallest possible here on the graph. Okay, so here's where it is that the reference angles come in. You may see problems where you have to solve for a particular trig function and you're given a certain angle and you don't know what to do. Okay, so I'm just going to break down this graph little by little. We already started off with this diagram before. Now we're going to add on to it. This 1 that I have here in the corner, this just stands for quadrant 1. Quadrant 1 is where my reference angle will be, like we just talked about before. Quadrant 2 is next to it, then there's quadrant 3, then there's quadrant 4. Okay, if I'm given an angle, okay, that's somewhere between 90 and 180 degrees, okay, let's say 200, let's say 100, 120, examples like that. The first thing that I would do is I would figure out what my reference angle is. So in the case of 120 degrees, I would do this, okay, 180 minus 120, which would end up being 60, okay? So I would know that my reference angle is 60 degrees. My reference angle tells me a certain value. Now you've probably already learned about the three functions, sine, cosine, and tan. There are certain values that you probably have to memorize that are particular fractions that contain square roots and decimals even for 30 degrees, 45 degrees, and 60 degrees. That's why it's important to know how to solve for these reference angles. Okay, and then there are rules for these other quadrants as well. So if I'm somewhere between 180 and 27 degrees, I can find my reference angle by taking that, plugging it in for x, and subtracting 180. And then there's also a rule here for the fourth quadrant. So let's actually, rather than me continuing to tell you about this, let's actually try an example. So I'm going to go ahead and jog your memory and let you know that sine of 45 degrees and cosine of 45 degrees, it's equal to this number here, or this expression here. I'm just going to go ahead and highlight it. Okay, this is square root of 2 over 2. Okay, we're going to use this in a bit. Let's say that I asked you to figure out what is the value. Okay, the question would be, what is the exact value of sine 135 degrees? The first thing that I would do is I would find a reference angle. Okay, but see, well, what quadrant does it fall in? It's in quadrant number 2. It's between 90 and 180. So I would use my formula that I have here, and I would do 180 minus 135. That would tell me that my reference angle is 45 degrees. How do I use that? Well, do it like this. Since this is my reference angle, I can solve for what sine of 45 is. I just told you that sine of 45 is equal to this value here, radical 2 over 2. That's the first step. The next step is as follows. There's another key point here. Depending upon what quadrant my angle fell in, and I'll actually just draw it here, and it would be, something kind of like this. It falls somewhere in here. So this is 135. Okay, I'm in my second quadrant. Okay, each of these letters here that I just put here stands for something. Okay, I'm going to write it here. This stands for all, this stands for sine, this stands for tan, this stands for cosine for each of the trig functions. All that these mean is depending upon what quadrant that I fall in, each of these is positive. So in the third quadrant, tan is positive. In the second quadrant, sine is positive. That means by default, cosine and tan in this quadrant are negative. The only one in which all of them are positive at the same time is in quadrant 1, hence all over here. Okay, so step 1, sine of 135, well, the value is square root of 2 over 2. Second step, what quadrant am I in? I'm in quadrant 2. Sine is positive in quadrant 2. That means that my final answer for this would be, I'm just going to put an arrow here, positive radical 2 over 2. If it wasn't sine, if it was cosine of 135. Cosine is not positive in the quadrant 2, so I would put a negative here. Okay, I'm going to try one more time. Cosine of 225. Okay, where does that end up falling? I'm going to choose a different color here. That ends up falling in the third quadrant, somewhere in here. This is 225. I apologize for my handwriting. 225. Okay, I would use this formula here. When I plug in 225, my reference angle, and this is done on purpose, it also ends up being 45 degrees. So I know what cosine of 45 is. Cosine of 45 is what I told you before. It's the square root of 2 over 2. And then the last thing is I have to check to see if it's positive or negative. In quadrant 3, okay, in quadrant 3, it looks like I have the letter T, which stands for tan. Tan is positive. That means the others are negative. So by default, since this is cosine, not tan, this is negative square root of 2 over 2. That's how I use reference angles.